So good noon, good afternoon. Yeah, good afternoon, 12:05. Pre-calc friends. So I took a quick look at your previous homework assignment on sequences. They looked pretty good. So we're ready to move on to arithmetic sequences. There's also geometric sequences, and we'll get to that next time. I'm still trying to figure out exactly how we're going to wind up here. We should be our last test, whatever, not final exam. Last test should be Tuesday. So we got today's lesson and Thursday's lesson, and that's going to be, I think. So stand by for more details. All right, so let's go through this quickly so I can have some lunch and go to my 1 o'clock meeting. All right, so a sequence is arithmetic if the difference between consecutive terms differences, are the same. In other words, it's always the same difference between the first term and the second, and the third and the fourth, and the eighth and the ninth, etc. That difference is cleverly called the common difference. So let's look at some examples. We've already actually seen some examples of this in the previous section. So 2, 5, 8, 11. Well, let's see what the difference is. 5 minus 2, 3. 8 minus 5, 3. 11 minus 8, 3. The difference is always 3. Arithmetic sequence. Let's check this one. 7, 1, negative 5, negative 11. So let's check it out. 1 subtract 7, that's negative 6. Negative 5 minus 1, negative 6. Negative 11 minus negative 5, negative 6. So the common difference is negative 6, and this is arithmetic. Same trick here. 3 and a seventh minus 3, 1/7. 3 and 2/7 minus 3 and 1/7, 1/7. You get the idea. Okay, so I want us to be able to write the formula for the nth term of the arithmetic sequence whose common difference is 5 and whose first term is negative 1. Okay, so we actually have a little formula for this, and here it is. Our nth term of an arithmetic sequence is given by the common difference, d, times n, which is the number of the term, right? And then plus c, there's going to be some little constant. So as you can imagine, this looks just like y equals mx plus b. This is a linear sort of relationship. Okay, so we're just going to plug the stuff in here. So we know the common difference is 5. That's d. And the first term, n, that's 1, is negative 1. So that's that. So it's pretty simple. So we got negative 1 equals the difference, which is 5, times, in this case, the first term. That's the term we're working with, right? The first term, number 1, plus c. Well, we're going to find out c in just a minute. So 5 times 1 is obviously 5. Subtract 5 over here, so c must be negative 6. And so the formula for our nth term is 5n minus 6. And let's just check that for our very first term here, see if that works. So if we plug in 1 as our index, the number of our term, 5 times 1 is 5, minus 6, negative 1, boom, there it is. This is our correct answer. And this is our special formula that we need to work with. We're going to use this several times. Okay, so easy stuff. All right, and it's nice that we're kind of ending the year on some easy stuff here. All right, so the 8th term of a sequence is 25. The 12th term is 41, right? The first 5 terms. So what we really need to do here first is, as you might imagine, find the common difference, because that's really the most important thing in all of these sequences here. So we know, like I said, that the 8th term is 25 and the 12th term is 41. So the difference between these two guys is 41 minus 25, that's 16. And there are 4 terms that separate them. And so 16 divided by 4. So the common difference here is 4. So common difference is 4. I'm going to use that down here. So I'm going to say that d equals 4. Because I'm going to use that here on this part. But I want to work backwards first. Just kind of use some common sense here. So we want to write the first 5 terms. All right, well, I know the 12th term is 41. I know the common difference is 4. So I can just kind of count backwards here. So I got 41 over here. And then subtract 5, I got 36, 31, 26, 21. It's going to be a nice little pattern here, right? Oh, crap. The common difference is 4, not 5. Okay, let's try this again. So 41 minus 4 is 37. It was just not feeling right. And then this is 33. This is 29. 29. Subtract 4 is 25. Subtract 4 again is 21. Subtract 4 again, we got 17. Hopefully I don't run out of room. 13, 9, 5, 1. All right, so what term is this? This is the 12th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more time, so I got to subtract, and I got negative 3. Okay, so these are my terms here. Negative 3, 1, 5, 9, and so on. These are all my terms. Okay, so we want to write the first 5 terms. Well, there they are. 1, 2, 3, 4, 5. There they are, negative 3 all the way up to 13. So that's one way to do this, just kind of thinking backwards, working backwards. That's one way to do it. So, so we can also use the formula to help us to find actually the formula for the terms, and then use that formula to just generate the first 5 terms. Okay, so we know that the difference is 4, and so let's pick a term that we know. So we know the 8th term is 25. So 25, that's the 8th term. And the common difference is 4. And that was the 8th term plus C. And so we got 25 equals 32 plus C. And so we subtract, and so C must be negative 7. So our formula is A sub n, equals common difference 4 times n minus 7. And then we would just generate the terms by just putting 1 in there. So the first term, so 4 times 1 is 4, minus 7 is negative 3. The second term, 4 times 2 is 8, minus 7 is 1. And you can see that we're starting to generate the same thing. So this is the other way to do it. Create a formula first, and then generate the terms from the formula. Okay, so there is a story. I wasn't there at the time. This is in the 1600s. So I don't know that this is true, but I've seen it often enough. So famous mathematician, Gauss, Frederick, I think was his name. He was developing calculus at the same time Newton was, but Newton just got there first. Anyway, Gauss was a brilliant mathematician, and the story goes that he was very bright and also kind of annoying as a elementary school student. So one time he was being annoying enough that the teacher decided to punish him, and the punishment was that he had to add up all the numbers from 1 to 100. A few moments later, he gave the correct answer. So the teacher was just stunned because he knew what the correct answer was, and so did she. It was 50-50. That gives us, so the method that he used for figuring out the sum of those terms was he just said, well, I know that the first number in our whole group of numbers is 1, and I know the last one's 100, and I know that the second one is 2, and I know that the second to last one is 99, and 3, and don't worry, I'm not going to write all these out here because that would take forever, but I can recognize this, that I know that 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, and as it turns out, we have 50 of those pairs, so it's 101 times 50. 101 times 50, which turns out to be 5,050. But this also gives us a way of finding out the formula for the sum of a finite arithmetic sequence. So we're going to write S for the sum, and we're going to use what Gauss did. He said, well, you know what I'm going to do? I'm going to add the first number and the last number. So I'm going to do A1 plus the last one, A sub n. And I'm going to divide that by 2. I'm going to write that over here. I'm going to divide by 2 right here. And then I'm going to multiply by I'm going to multiply by the number of pairs that I have, which is really n over 2, right? Because we had 100 numbers, divided by 2 is 50. So here's the number of pairs, and here's the sum of each of the pairs, the first one and the last one. Very clever. So there's your formula for the sum of an arithmetic sequence if we know the first term and the last term. So that's our formula. All right, so we get a chance to use that formula straight away. All right, so it says find the sum of the sequence. There it is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 of them. So the sum equals 12 over 2 times the sum of the first one and the last one. So easy enough. So we got 26 here and we got 6 there. So we got 6 times 26 equals 156. And that's it. Just some nice formulas to work with, easy stuff. All right. So it says write the formula for finding the sum of the first n counting numbers. Okay. So we're actually going to use what Gauss used here. And so let's just take a look here. So we got 1, 2, 3, dot, 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 n. So we know that we can use our little sum formula here. So we got sum equals, so the number of pairs, well, I know that I'm going to have this many numbers, so I'm going to have half of that as my number of pairs. So that's going to be n over 2. And then I'm going to multiply that by the first one plus the last one. And so this formula is more commonly written as n times n plus 1 over 2. So if you want to find the sum of the first 137 numbers, just plug them right in there and we're done. So this is the sum of the first n numbers. First n counting numbers, I should say, right? First n counting numbers. So for you soccer players, that's reminding me that there's a match that starts in 13 minutes, 12:30. There's a match that starts. So I'm only going to see a little bit of that before my meeting. All right, so find the 50th partial sum. So remember, a partial sum is not all of the numbers added together, because that'd be an infinite sum, but just the first 50 of the numbers in this sequence right here. So what we need to know, of course, is, because in order to use our formula, we need to know the first term. We got it. We need to know the last term. We don't got it. But we can figure out the last term because we can always find the formula for the sequence using our generic formula right here. So we got n times d. Did I write dn before? I don't remember. Plus c. So I can just pick any of these terms that I want. And so let's first find the common difference here. So as I look at, let's just start here. 10 minus 6 is 4. 6 minus 2 is 4. 2 minus negative 2 is 4. I bet the common difference is 4. So we got 4 times n. And let me just pick a nice number to work with here. Let's work with 10. That's the 1, 2, 3, 4. That's the fifth term. So that's going to be, actually I should have done this. So I should have said 10. That's the fifth term. 4 times 5 plus c. So I'm going to, so that's 20 obviously, so subtract that. So I got c equals negative 10. So my generic formula here is a sub n equals common difference, which I discovered to be 4 times the index, and then subtract 10. Okay, and let's just check to make sure that actually works for our very first term here. So n is 1. So 4 times 1 is 4, subtract 10 is negative 6, boom, it works. So there it is. There's our formula for the first, or for the nth term, and what we want to find is the 50th term, because that's how we're going to find the 50th partial sum. We're going to add up the first 50 of those numbers. So we're going to plug 50 right in here. So 4 times 50 is 200, minus 10 is 190. So a sub 50 equals, what did I just say, 190? 190. Okay, so now I know the first, and the last, and how many? So I just use my little formula. So S equals 50 over 2 times the first one, negative 6, added to the last one, 190. So 50 over 2 is 25 times 190 minus 6 is 184. And 25 times 184. 25 times 184 equals 4,600. 4,600. And there you go. Okay, last problem. And it involves a chess tournament. So, at a chess tournament, the top 10 finishers get prize money as follows. First place gets $500, second place gets $480, third place gets $460, and so on. So what we want to know is, what was the total paid out in prize money? Well, this problem is really just the previous problem with different numbers. So what we want to know is, what's the sum of the first 10 numbers in this sequence right here? Well, so what we need to do is we need to, and we could do this fairly easily, right? I just want to make sure we're practicing the methods. We could just keep subtracting 20 and get to our 10th term pretty quickly. But I just want to make sure that we're still good at this. So remember our little formula here, ND, okay, 10 minutes till kickoff, ND plus C. And so the common difference here is obviously 20. And let's pick a term here. Let's pick the third term. So we're going to do 3. And the third term is 460. And of course this would work with any term. We could pick any of these 3 terms. That would work just fine. And so 3 times 20 is 60. Subtract 60 over there, so C must be 400. So A sub n equals 400. Something is not right here. Okay, common difference is 20. The third term is 460. Subtract 60 over, that's 400. C is 400. A sub n equals, common difference is 20. 20n plus 400. Something went bad here. First term, that would be 420. Oh, the common difference is negative 20. That's just silly. Okay. The common difference here is negative 20. There we go. Negative 20. So that's not this right here. Right, we're decreasing by 20, not increasing by 20. So then this is going to be negative 60. So add 60 over, that's 520. Much better. 520 equals C. So there it is. Our formula is going to be negative 20n plus 520. There we are. Now we're on track. And it's good to check, obviously, as I just did, and found out that I was incorrect. So plug in number 1, or plug in 1 here. Negative 20 times 1 is negative 20, plus 520 is 500, and there it is. All right, so we need the 10th term. So we're going to put in the 10th term right here, 10. So A sub 10 equals negative 200 plus 520. And most of you are saying, you know, we could have had this a long time ago. And that's true. But of course, I give you a fairly simple thing here with only 10 finishers. But, you know, if this number was 100 or 1,000 or something like that, and obviously it wasn't a chess tournament, it was something else, you know, you get the idea. All right, so 520 minus 200 is 320. So the 10th term is 320. The first term is 500, and we got 10 of them. So the sum is going to be 10 over 2 times 500 plus 320. So that's going to be 5 times 820, or 5 G's, right? 4, yep, $5,000. Yeah. No. I'm going to check because I don't trust myself anymore. 820 times 5 equals, oh, there we go, 4,100. Yeah, I went 1,000 instead of 100. Equals 4,100. Okay, well, good thing my feelings were operating correctly. So there it is, 4,100, not 5,000. Drugs. Okay, there it is. There's a fairly short lesson for y'all. And yeah, that's it. So I will see you all on Tuesday. And that's going to be our last lesson, looks like. And yeah, so be safe. See you then. Bye.